presenting about my passion in clams, which I discovered about in 5th grade. But first, yeah, I'm Erica Yasuhara, and I am a neuroscience major at Wellesley College, and I'm a first year. But my presentation is going to be integrating biology and technology and environmental science. And so this is about integrating shellfish with technology and revolutionizing water quality and marine conservation. So, okay. So currently there's many regions in the world affected by water scarcity. And this is a heat map that shows many areas with the worst water accesses. And so over 80% of the marine population comes from land-based activities, including agriculture runoff and treated sewage and plastic waste. So two real world examples that happened recently is Hurricane Maria, which happened in Puerto Rico in 2017, which left millions without access to clean water due to damaged infrastructure. And here is like a before and after of the effects left by Hurricane Maria. And so natural disasters can disrupt water supplies, leaving communities vulnerable to waterborne diseases. And another example is the polluted rivers, which impact communities such as the Ganges River in India, and which has high levels of industrial human waste pollution. And here's a photograph constructing, yeah. Here's like a photograph of the Ganges River in the bottom. And so polluted rivers not only harm ecosystems, but also directly affect the livelihoods of and the health of millions. And so the problem here is that the traditional purification systems are very costly. So modern purification systems, cost billions annually worldwide. And a real world example is the US, which spends over 100 billion per year on water infrastructure, which is estimated by the EPA. And the cost of water treatments versus the GDP of low-income nations is crossing over, as we can see in the bottom graph. So like the demand is higher than the amount of money that is available to supply these countries with costly infrastructures for water filtration systems. So the issue here is like it's very unsustainable. So traditional systems are resource intensive, which means it depends on significant energy inputs and generates waste products such as concentrated brine from desalination. And it is a fact that desalination plants produce approximately 50% more brine than potable water, which is sourced by the UN. And another issue is the limited access because many areas, as I mentioned before, still lack access to these systems due to infrastructure and economic barriers. So I want to introduce something else, which is the nature potential to potentially offer better sustainable solutions for water purification systems. And right now, nature already does provide effective low energy water purifications, such as wetlands and shellfish. And natural systems operate without creating waste byproducts, and they restore ecosystems as well. So yeah, so purification by natural systems can be more cost efficient. And there are many innovations currently as well that can or do use more natural systems. And we'll take a deeper dive into that in a later slide. So as a brief overview, clams as water purifiers filtrate particulate matter, algae, and even bacteria from water by drawing it through their gills. And a single adult clam can filter up to 50 liters of water per day. And other organisms can also do this, such as plankton, which absorbs pollutants and help clean water by contributing oxygens, or while contributing oxygen. And bacteria also degrades organic pollutants, and absorbs heavy metals. And wetlands also, such as like cattails and reeds, also filter water naturally in marsh ecosystems. And so the key point here is that these organisms collectively maintain water quality and balance in aquatic systems. However, the reason why I decided to study clams is because of their efficiency, because clams can filter water continuously with minimal energy expenditure, and their filtration process is passive and does not produce harmful byproducts. And there's a dual benefit here as well, because it improves water quality, but it also reduces harmful algal blooms by removing excess nutrients. And it is very resilient because it can adapt to various aquatic conditions, making them versatile in both saltwater and freshwater environments. And compared to modern systems, clams, unlike artificial systems, are self-sustaining and integrate seamlessly into ecosystems. So, here's like a close-up image of clams filtering water, or how their process and how they're integrated into the ecosystem. And so the key question here could be, how exactly do clams work their magic? So we're going to take a closer look into that, and in the next slide. So here I'm going to show you a video of like an example side by side of water without clams and water with clams, and you can see that it like within or less than 2 hours, the clams filtrate the water from murky to very clear, and it also disintegrates the bacteria through their filtration systems. So as clams draw water in, microscopic particles and pollutants are trapped in mucus on their gills, and then clean water is expelled through their exhalant siphon. And the importance here is that the filtration process not only improves water clarity, but also balances nutrient levels in the water, which prevents harmful algal blooms and maintains the ecosystem health. And so here's a diagram of a clam structure. And so the basic components that come into filtering the water for clams is, so here we have the inhalant siphon in the bottom, which is where the water enters the clam, and then the exhalant siphon is where the water exits. And then, so first the water containing the food particles enters the clam through the incurrent siphon. And then there's a ciliary action that happens as water flows over the gill filaments. The cilia beats rhythmically, creating a water current that moves food particles towards the food growth. And then the mucus capture, which is where the food particles adhere to the mucus coating the gill filaments, and food transport, which is where the trapped food is transported along the food groove towards the labial flaps. And then sorting by labial flaps, the labial pulps further select and sort the food particles, directing only the desirable ones onto the mouth. And then excretion, where the clean filtered water is expelled through the excurrent siphon. And so clams are considered a keystone species in aquatic ecosystems. Due to like the many of the reasons I explained before, such as improving water clarity, reduction of harmful algal blooms, but it also is a creation of habitats, because clam shells and beds provide hard substrates for other marine organisms such as barnacles, sponges, and small fish. And these habitats enhance biodiversity and support food chains and aquatic systems as well. So other additional environmental benefits for clams include nutrient recycling, which is where clams redistribute nutrients through their waste, which fertilizes aquatic plants, and sediment stabilization, where clam beds anchor sediments, preventing erosion and reducing turbidity, and then also carbon sequestration, which is where the calcium carbonate in clam shells locks away carbon, helping mitigate CO2 levels in water. And longevity, insights, and resilience for clams, such as the lifespan of clams, where clams can actually live for decades, with some species living over 100 years. Their longevity makes them stable, long-term contributors to the ecosystem health. And also the clams' resilience is one thing to note, where clams can tolerate a range of saltiness and water conditions, making them adaptable to changing environments. For example, freshwater mussels have been used to monitor and improve water quality in degraded rivers. And there are some real-world examples where clams are integrated into these filtration systems, such as the Chesapeake Bay restoration case study, which they reintroduced clams and oysters, which has led to measurable improvements in water clarity, biodiversity, and algae control. And clams perform similar functions as artificial systems, but at a fraction of the cost and energy input, as mentioned before. So now that we see the profound ecological benefits of clams, one question we can consider is if we can harness their abilities to create sustainable solutions for human challenges. So there are many threats to our current ecosystem, such as pollution, habitat destruction, and overharvesting of clams. And especially the overharvesting of clams is a major issue currently. So that can cause industrial runoff, such as heavy metals, oil, and chemicals poisoning clam habitats and reducing their population and filtration efficiency. And clams also are currently ingesting microplastics more faster than ever because of a lot of the pollution and waste destruction that enters our oceans. And the nutrient overload, which is causing agricultural runoff, leading to eutrophication, depleting oxygen, and creating dead zones where clams cannot survive. So as like rising sea temperatures and ocean acidification weakens plants' shells and disrupt ecosystems due to climate change, it's potentially disrupting the ecosystem for the clams. And also the overharvesting, which is there's a real world example where the decline of freshwater mussels in the US are happening. The decline of freshwater mussels in the US are happening due to overexploitation. And we can even see here the on the right hand side where they're like overharvesting clams. And a couple of things that we should also consider though is how, as I mentioned before, the Chesapeake Bay project where they're reintroducing oyster and clam bed restoration, which has had measurable improvements in water quality and ecosystem health. And since 2010, oyster restoration in Chesapeake Bay has increased water clarity by 40% in targeted areas. And another example is marine protected areas where designation of no harvest zones allows clam populations to recover and rebuild ecosystems. And so it's really important to note that people should start being more involved in the community through like local communities participating in sustainable harvesting and restoration projects. And an example can be like a fisherman-led initiative in the Philippines to restore mangroves and plant beds. So conservation matters because of ecosystem balance, because clams play a critical role in maintaining water quality and supporting biodiversity. And losing clams would destabilize aquatic ecosystems. And the economic and social impact that clams provide is how clams provide livelihoods for millions through fishing and aquaculture, and their decline threatens food security and local economies as well. So here I'm gonna introduce some like direct ways and technologies that clams have been used recently. And so introduction to nature, inspiring engineering. Nature has evolved highly efficient and low energy solutions over millions of years. And by mimicking or directly utilizing these systems, we can develop more sustainable technologies. And I can show a real world example of a DIY that someone made. So here, This is a DIY swirl filter with clams, and this is only with the use of clams. Yeah, so as we can see, even with only natural systems, it's very applicable in the real world, and we can definitely use it to even replace some technology. And because clams isn't, or like, because clams are low cost and ecosystem restoration, or can be used for ecosystem restoration while purifying water, it's a very viable solution to many costly challenges that our world faces with water purification. And it's also very simple in its implementation as well. So there are some developing systems inspired by clam anatomy, which mimics the structure and mechanism of clam gills to create artificial filtration systems, such as like nanofilters, which are designed to trap particles as effectively as clam gills, and hybrid systems which incorporate clam beds with mechanical filtration for scalable solutions, as well as 3D printed biofilters modeled after clam siphons and gills. And these benefits include scalable to industrial levels, and it also avoids ecological risk associated with live organisms. And other examples of bio-inspired engineering include nanotechnology filters, such as filters with nanostructures mimicking the gill's ability to trap particles and allow clean water to flow. And filters made from graphene or advanced polymers with clam-inspired designs, which has a self-cleaning property inspired by clam cilia movements. So there definitely are other ways to incorporate the clan structure to create a less costly and very efficient way for water filtration. And so, as I mentioned before, and the bigger implications of plants can include like enhancing biodiversity by providing habitats or improving water clarity. I mentioned restoration projects where the Chesapeake Bay Restoration used clams and oysters to rebuild marine habitats and improve water quality. And then there are other scalable solutions as well, such as using the structure of clams to create technologies, as well as you can use clams for wastewater treatment and aquaculture ponds. And you can also use clams like biofilters to offer cost-effective water purification systems for rural and underserved areas as well. And so why clams, like some may ask? Well, clams like ocean quahog live over 400 years, and their longevity offers clues about the resistance to cellular damaging and aging. And understanding these mechanisms behind their slow aging processes can definitely help us understand how and why, or like different ways we can implement clams or other like natural resources to solve a lot of our issues. So the interdisciplinary impact of marine conservation and water purification could address multiple global challenges across our world. And some future directions that I would like to take is explore the species adaptability to different water environments, as well as researching into how freshwater mussels and saltwater clams perform under varying pollution loads, nutrient levels, and water temperatures. Yeah, so thank you so much for listening to my presentation. This was like more of a just explaining some things that I have like found out recently based off of my interest in like clams when I was like younger. So I'm definitely gonna take it from here to like learn more and like research more on clams to see how they can like survive in different types of environments. But I'm willing to take any questions. Mhm. So the Chesapeake Bay project is like just one of the examples that happened recently, and it's very uncommon for people to recently do these like procedures and like understand like how important clams are to the ecosystem. But there definitely are, it's not like it was more of like the community being more involved with their like um resources and as a community like trying to change things for their own community. And the thing is, like a lot of our communities recently haven't been really like trying to involve themselves to try to help like nature and like the ecosystem. So it is just like one example, but there definitely are other examples out there. Thank you so much again for the informative, useful presentation. Thank you again.